Good evening, class. Tonight we're going to talk about some gas piping. This is the assignment that you had last Wednesday. Let me adjust the screen a little bit. Yeah. Okay, I think that's a little better. Okay. All right, I got it a little bit closer. Hope you can see the numbers on there. Okay, what I did is I kept the same as I told you last week. This was the private home that I used as a sample, and the first two questions involved just doing the boiler and the water heater. And we used it at a distance of, I believe it was something like 70 feet, 80 feet. Okay, this one here, actually it was 80 feet. I still have that over here, which we're not using tonight. Let me change that. Okay, just as a refresher, we changed this to 101, right, for tonight's problem. That way, it would obviously change the answers because it was such a great distance. Now, normally you wouldn't be going 101 feet, but if it was a long, big ranch house, for example, it's possible. You could put something on diagonally in the back of the house outside, a gas fireplace outside. So it's possible. But remember, 101, just for your information, whenever it goes over, even by 1 foot, you bump it up to the next one. So if you look on your chart, 101 becomes, I'll put it down here, 125. Now, I believe I said that kind of quickly, but I mentioned that just before we wrapped this one up last week. Okay, so the distance on this problem, 125. Now, I know this wasn't done for our advantage, but remember, by going always to the same number rather than different numbers up here, the distances, it is kind of a built-in safety factor, but it makes our life much easier. All right, those of you who have actually sized gas pipe for real life in real life out on a job site, I think you'll agree that when you just go to one column or reading the footage and read across and just stay there, it makes it a lot easier. Also, you're not going to make a mistake. It'd be a lot less likely that you make a mistake by doing it this way. Okay, so let's leave it there. We're going to 125, even though these first few appliances are much closer. So on paper, what I'm saying is that this fireplace now has jumped up to 125. Okay. Also, what I asked you to do was to add 10,000 BTUs to all of these appliances, which keeps them still in the realistic ballpark, but enough that it might, remember I'm saying might, change the size pipe that serves each of these appliances. Okay. Now, with that, what I'd like to do is to go over what I have here. Now, what I did honestly was to erase what I had to and just uh, put in the new numbers. Okay, so right off the bat, if you have your sketch for or your problem from last week, the one I used as a sample, you'll notice I just kicked these up by 10. All right, which kicks this up by 50. All right, so if you look at the old problem, I believe it was, I don't have it right here, but I believe this was 415. Okay, so if you get something other than 465, you got a problem with the numbers. You might get lucky and it might not affect the pipe sizing. The pipe sizing occasionally falls very close to the capacity, but usually it's not that close. And if you make a slight error, it's not going to change anything. All right, so let's take a look. The boiler bumped up to 160. The water heater now is 75. The stove is 55. The dryer is 85. And the gas fireplace is 90. Okay, and the distance, they're already crossed out. I put them up here, and then I just X'd them all out. And this is the same thing. Okay, so these numbers here are nothing that you have to concern yourself with, right? Just eliminate them right off the bat. If you're on a job site or you're working off a blueprint and you know where the furthest appliance is going to be, it's a little tricky to get you can look down on it and you can get the horizontal distances, but the vertical, like where you come through the wall, you might go up a foot or two, cross and down and so on. That's hard, a little harder. But if you're working off a print, or even better, if you're on the job site, although you want to price it, you're going to have to price it before you actually get on the job site. Probably not going to be working by the hour, not on a new house. So we come up with this number here for BTUs, grand total, and 125. Remember, just a refresher, the 465 is input. How much gas does this appliance take per hour to operate? Remember, all of these numbers here are the appliance input for 1 hour, continuous use. All right, so let's go over here, take a look. All right, we have our meter outside right here, and we come into the building. Now let's go to take a look at your chart. That chart is on page 5425, right? If you have a code book, it's a couple pages past the actual tab that has gas chart. And if you have the handout sheet from last week, you can use that. Okay, so we go to the column that says 125, and it happens to be just below a line on the chart, which makes it a little easier. What I would suggest you do is get a ruler and lay the ruler down so that you are always on 125. So you don't have to keep looking over. Okay, or a straight edge of any kind. A ruler obviously would be the easiest thing. Okay, so let's go across. At 125, let's go across to the smallest number that can handle 465. So it's got to be 465 or greater. All right, in this case, we're coming up to I'm looking at 355, not big enough, 532. Okay, that will do it. And then read straight up. Looks like 1.5. So this whole thing here will be provided with 1.5, and it's right here. All right, I'll circle these as we do them. Okay, so the first one, coming from the meter to the first split, is going to be 1.5. Okay, then we're going to have a T going over to the boiler. We'll deal with that later. All right, after the boiler, we got rid of the boiler. So what do? Okay, the second appliance is going to be the water heater. So between the boiler and the water heater, I have it right here. 465, we got rid of 160,000 BTUs right here. So here's where we are, between here and here. Okay, we dropped off 160 from 465, very easy, 305. Let's go back in the chart. So in the chart, you go across 125, you go across until you come up to the first number that will handle, was that 305? And the answer is 355. Okay, and that is 1.25 inches. Okay, here we are right here. Now, as you can see, I've already got these done, but I'm just double checking my own work. Okay, so what you did here is you're starting to telescope down. You're going from 1.5 1.25 inches, and obviously we're going to be coming down to 3/4 at the other end, at the far end. And I'm only going to mention this one more time. If it's for a customer, especially some customer you've got a good relationship with already, or a contractor who's doing the job like a custom job, you could suggest, although a good contractor would probably be aware of this, but you could suggest I could run an 1.5 inch header from here to the end. All right. Also, 1.5 inches will go up to 532. And we had 465. All right, that'll give you an extra like 80,000, 80,000 BTUs. Now, because of the distance, this is a little out of whack because normally you wouldn't be coming in a house this size with 1.5 inches. I think most of you who have done houses, you'd be coming into this one with 1.25 inches. But in any case, you could run a header from here, we'll say to the end of the house down here, and just drop these off along the way. That way, at some point, they could add to it. If they didn't, and you did it as the way we're doing it right now, what you would have to do if you had something else, we'll say even further, you would have to tie it in back over here somewhere where there'd be enough BTUs available. But if you telescope down and it was running a little tight, the whole thing was a little bit tight, but legal, there's nothing you could use. You'd have to go all the way back to the meter itself. Very, very expensive. So to avoid that, you could tell somebody, look, if you want anything you think you might, I can run a bigger pipe now and it'll handle it. Now, is this code? Absolutely not. So if you want to just forget what I just said for the last 3 or 4 minutes, go right ahead. You don't need it for your license. It's just good policy on the field. Okay, so let's get back to it. We did 1.5 inches. We have a T. Oh, you can see it's 1. I'll tell you right now, this is 1 inch. We'll come back. What we'll do is go down the end, then we'll double back. All right, so this will be 1.5 inches by 1.5 inches by 1.25 inches by 1 T. All right, so we're coming across here. We got 1.25 inches. Now we come to the water heater. So what are we going to do? Well, let's take a peek. We drop off the water heater, which is 75, which gets us down to 230, right? So at this point right here, right after this water heater, from here to the stove, we got 230. So let's go into the chart. 125, go across until you have 230. And we got 173 at 1 inch, not enough. 355, so we're still 1.25 inches. So this here is going to be 1.25 inches by 3/4 T. All right, so we're holding the same size pipe. All right, now we're dumping off the stove. Okay, and the stove is going to be right here, 200 1,000 BTUs. Oh, hold on. Looks like I made a mistake here. I did make a mistake. 265 minus 75 is 190. Hopefully that won't change anything further on. Well, let's find out. Okay. So we have what is going on here? 5. Hold on, got to do a little bit of math, refiguring here. Let's see, 265. Okay, look, I'm going to have to do some math on it. I'm not going to delay for 10 minutes messing around with the math. Okay, sorry about that. I do have a few other things I wanted to go over about gas piping. All right, we have a couple of things here that you should be aware of. Some of you might be already because you've installed these on your own or with very little supervision. If you put in a water heater, but especially a boiler, notice what the manufacturer's directions tell you. Okay? Check out the directions before you start putting it in, because there's going to be one side of the boiler that you might have to get at, you probably will have to get at, especially if it's oil, where you have to clean it, right? Where you have to take one of the sides off to get at it. And they'll tell you need, like, say, 18 inches, 24 inches, or whatever. And they might want a clearance all the way around the boiler of a minimum of, we'll say, a foot, just for safety, for fire safety. All right? So take care of that. Be sure that you have enough room in advance, because if you put it in and you put it in a tight corner, especially where you have to access one side or the other and you're up against the wall, especially a combustible wall, it's another thing to be aware of. Now, most boiler basements, if they're unfinished, you don't have any combustible walls. They're usually cement walls when you get near a wall. But some houses already have some walls in there. Be careful. All right, they might tell you to be so much, such and such a distance from a combustible wall or any wall. And in the front, of course, you need plenty of clearance in the front. I think we're all aware of that. Also, now when you do cement blocks, you're going to have to get solid blocks. I think I told one of you two classes to use solid blocks, but the reason is the hollow blocks don't work out very well. Hollow blocks are designed to be used straight up with the holes when you look down on it, right? They're fine. They're good for construction. They save some weight. They save some money for the owner. They've been around a long time. However, they don't work out so good for the feet on a boiler in particular because they always have 4 feet. On an electric water heater, usually they have a flat bottom, but still, don't use hollow blocks. Get solid blocks. Now, gas boilers, I would recommend not less than 4. They call 4x8x16 solid. Some of your suppliers do keep these bricks in stock, and they put them maybe on a loading dock. I think it's Plumber Supplies to do this. I'm not sure about Robinson. Anyway, they might have a pallet as a convenience to you, so you don't have to go chasing them. Now, we used to have a place, maybe a few of you older guys might remember, called Building Materials. It was down off of, let's see, Plymouth Avenue and back of Southeast Supply, kind of in back to the left. Anyway, long gone, but they had all masonry supplies. So you might have to look around for these blocks. I suspect you can get them at possibly Lowe's or Home Depot. I haven't tried, but you could check with them. Now, if you got a basement that's wet, what I suggest you do is use 8-inch blocks. If the cellar floods, or you suspect it might flood someday, put it up on 8-inch blocks. It doesn't hurt anything. It makes a really nice platform. Solid blocks, you can make a nice square out of it. Those of you who have used it know what I'm talking about. It ends up with a little hole in the center, but it doesn't matter because the feet are on the outside of the boiler, right? Towards the outside. Not a problem at all. Okay, but a minimum, use 4-inch blocks. Okay? It protects the boiler from a flood, that many inches, and it makes it a little easier to access because it's a little higher. And even putting a hose on the boiler, depending on the design of the boiler. If it's a wet leg boiler, which we could talk about sometime, a wet leg boiler is kind of like an electric water heater. If you remember the electric water heater, the drain is so low that they have to turn it sideways so you can put a hose on it. And even at that, it's tricky. So electric water heaters, for you or the next guy that replaces that heater, makes life much, much easier if it's up on a cement block. Even 4-inch blocks are better than nothing. Okay, so use blocks. Not that expensive. They look good, and they protect the boiler or the water heater from a flood. Okay, and also, again, I know I talked about this, but I think it was only once with one group. Pitch on smoke pipe. Some of you might not know this. The smoke pipe, where you're running horizontally, you pitch it just like plumbing pipe. All right, so you pitch it a 1/4 inch to the foot. Okay, now usually we're within maybe a foot or two of the chimney, so the pitch is not an issue. And I've never seen an inspector really get picky about it and pull out a level or anything, none of that stuff. However, if somebody comes off a heater and tries to get it in a hole that's lower and you pitch it down, now you're going to hear about it. Okay, it's very obvious. Inspectors will see it, probably call you on it, and you're going to have the inspector come back, little reinspection fee. Plus, you're going to have to wait, and you're going to lose some time, and you're going to have to correct it. You probably have to take the pipe out, chop it a little higher, at least to get a little bit of pitch on it if possible, and cement up what you just tried to tie into. Okay, so don't forget that. You're supposed to have a little bit of pitch on your smoke pipe. Normally, we're not running smoke pipe very far. Now, I think unless we have some very now everybody here, I've had you in class now for 2.5 months, something like that, since the end of September. So everybody here has got a minimum of, we'll say, 3 or 4 months in. So I think you're all familiar with smoke pipe. But just in case we have somebody out there, tier 1, that's not. Smoke pipe, pieces of smoke pipe are half lengths, a foot, full lengths, 2 feet. Now, you can get longer lengths, unusual, If you're doing residential work, you might go a few years before you even see anything longer than a full length. I believe I've used them a handful of times in my life. They have like a 4 foot piece, if I remember right. Um, but even if you only have, if you need a couple of, you have to put a few full lengths together, 2 footers. Once you put 3 screws in, it really stiffens it right up. Okay, and you don't have to worry about it sagging down. Okay, which brings us to another point, which I don't think we talked about this year. When you put smoke pipe together, now on top of the water heaters, the old heaters that you guys are probably still taking out, they had the draft hood. That was that little hat thing that had 3 legs, and it should have been fastened down to the top of the water heater. That's something that came about, I don't know, maybe 30, 40 years ago, 30 years ago, 40 years ago, where they required us to start screwing the the pieces together and the draft hood to the top of the heater. Well, the draft hood is kind of gone. They got other things on there now with the new style of heaters, but the smoke pipe itself you still have to fasten together. All right, so when you're working with smoke pipe, don't forget you have to screw the lengths together. Now you should be using, again, when whatever your boss tells you to use, as I always make a joke of, that's the right way to do it. But when you do it on your own, you should have like a tripod set up. So 3 equally spaced screws all around the smoke pipe or rivets, whatever you're using. And that way it locks it so it can't move around, right? And you can suspend 2 of them without it sagging in the middle, right? So use 3 screws if you're doing your own. 3 half-inch sheet metal screws, self tap, right? And as far as hangers go for that, very unusual. We're going to need hangers. You can use the usual hangers. You could use even um, PVC hanger, right? Metal hanger, and strap iron, band iron goes by different names. This stuff comes on a roll. You could use that, but it's not common for us to have to hang smoke pipe. Right? We're normally much closer to the entrance to a chimney. Another thing, when you're going into a chimney with smoke pipe, if you have 2 different, let's say you got a boiler and a water heater coming in, and you're not joining them together, uh, the smaller one goes higher than the larger one. Okay. Now, if they join together, you have to get the right size T. You might have to do a little bit of math um, so that you can tie them together and put them in. Let's say a 3-inch smoke pipe coming from a water heater and a 6-inch boiler could definitely go into an 8. And I think if you do the math, you'll find it might even go into a 7. It's the area of the larger. We'll say that it was a 6-inch smoke pipe. Okay, that's a 6-inch smoke pipe. We'll say it's 30 square inches. It's just a little bit less than that. And you got a 3-inch coming in. The 3-inch would be just about 7. So you got 3 and 7. You have to add them up. It's half the smaller. So instead of being 7, it would be 3.5, right? Square inches plus the larger one. All right, we'll do that another time. That's obviously not really a lesson on the size of the smoke pipe, but you have to know how to do that. Now, one thing I found out the hard way, I want you to remember this. Let's say that you have multiple appliances. We'll say 3 water heaters, whatever it is, and it's going to require some custom fitting and smoke pipe and so on to go into the chimney. One time, uh, I I had a job. I had the permit out on the gas appliances, and a sheet metal guy was there, and he made this really fancy header and hooked it up. Man, it looked good. What I didn't realize was that even though I he did the work, I had the permit. I own that job. Anything he did to do with that smoke pipe was mine. Okay, and actually he did it right, of course. But don't forget that. So if you take a permit out for water heater, boiler, whatever it is, if somebody else does the smoke pipe, it better be right. Check it out because you're the one that owns it. Okay. Real quick thing on aluminum smoke pipe. Only saw this once. Uh, there was a problem with the bathrooms, again over the plumbing side of our license, and I think I told one group this year that nobody had a window in, and they forgot the fan. I could care less. I'm not doing that. I'm not doing the construction. I'm doing the plumbing. Well, apparently we are responsible to make sure, not that we do it, but to make sure that it's there. So, make a long story short, I teamed up with the electrician, who also probably could kill us, about ventilation. And I don't even remember. So many years ago, I don't know if we got paid for it. I think we did. I don't know. In any case, we worked together on it, which was interesting. And he got the he got the fan, and what we used instead of that flex like dryer hose was aluminum smoke pipe. Never saw it before, and it looked like our regular smoke pipe, except it was very light, snapped together, and we used that to take the exhaust, the moisture um, from the bathroom or whatever outside. Okay, so there is such a thing as aluminum smoke pipe, just that we don't use it. All right, is it legal for water heaters? Probably not. I've never seen it out there. Okay, um, I'm going to cut this lesson a little short. I'm going to square this sketch away. And what I also want to do is to start on a commercial sketch, which is obviously a scale up from what we've been working on. And we'll go from there. Okay, so I'm going to end this video right here, and we'll pick it up. I'll wrap up this sketch, and we'll start on some little bit of commercial work. Okay, see you a little later on.